This is multiplication with matrices. Alright, back to the pizza example from the last video. What if you decide to order this should say 4, as in the number 4. 4 of each of the pizzas and 4 of each of the salads, so 4 of everything. What would you do to find out the cost from each pizza house for each item? Okay, so when we're multiplying everything by a number, it's pretty simple. We're just going to call that a scalar. So if we want 4 of everything, we just put a 4 out in front. 4 is the scalar. As you can see below, we're just going to multiply each element within the matrix by 4. So changing it up a bit here, suppose you want to buy 4 pizzas with 2 extra toppings and 4 salads with 2 extra dressing containers. And this has been set up for us here, this algebraic expression, so 4 times matrix A plus 2 times B, okay? Because we want 2 of everything with a salad, but 4 of everything altogether. So first let's distribute, so let's take the 4 and do this. So that's going to be 4A plus, and then 4 times 2 is going to be 8. So really it's going to be 8B. So then the way we would set that up using just scalar multiplication is 4 times 12.16, 10.10, 10.65, okay, so 4 times all of that plus 8 times matrix B. Sorry, let's just say 45 and 0.5. Okay, and from here, I'm not going to finish this because really all you have to do is multiply the numbers out. So, for example, we would need to do 4 times 12.16 to get that element, and then 4 times 10.10. So just 4 times all of these to make a matrix, and then 8 times each one of these. And in the end, since they're both 2 by 3 matrices, we can just add them together to get a total cost for everything. Okay, next, how would you multiply 2 matrices? Suppose you plan on buying 4 packs of chips, 3 candy bars, and 2 cans of soda. And we're going to put that in a matrix here, and sorry, the words are a little jumbled. I'm going to rewrite that for you, so that should say A equals, the matrix is 4, 3, and 2. And, alright, the costs of the items can also be represented by a matrix, so let's see. You can see that one clear. I'm just going to rewrite it just in case, though. So 0.30, 1.15, and 1.59. And notice that the matrices are oriented differently. A is a row matrix and B is a column matrix. And we're going to talk about the rules for multiplying in just a minute here. So essentially, to find the answer to this question, how much is it going to cost total to get all this stuff, we're just going to multiply the matrices together. Here are those matrices again. So we have A. The A matrix is 4 bags of chips, 3 candy bars, and 2 sodas. And then over here in matrix B, it looks like the 0.3, that is going to represent the cost of each bag of chips. This is going to be each candy bar, and this is going to be each soda. So all we have to do is multiply stuff together. So if you'll notice, we take the 4 and multiply the 0.3. We'll do the 3 times the 1.5, and then the 2 times the 1.59. Okay, multiply those together. You can see that done in this step. And at the end, just add them up, and we get a total cost of 7.83. And notice the pattern here. We had the element of the first row and column times the element of the first row and column of the other matrix. And then we had the element in the first row second column times the element in the second row first column. So everything's kind of switched around a little bit. Same thing goes down here, A1, 3, so first row third column times the element in the third row first column in matrix B. And again, we'll talk about these rules a little bit more in detail coming up. Here's another example of two matrices that we can multiply together. There is a very specific rule for that, and which I'm going to discuss more on the next slide. But just notice that this slide this first matrix is a 1 by 2 matrix, and this next one is a 2 by 3. In order for matrices to be multiplied, these two inside dimensions must match, so 2 and 2. So we're good, and we can do it. And what we're going to end up with in the end is going to be a 1 by 3 matrix as our answer. So that's the trick there. Let's see. So what we need to do is take the first matrix. We're going to go horizontal with this. So if we say 3 and 2, we'll line up with 1 and 2. Okay, we're going to do that first. So 3 times 1. Okay, 3 times 1 plus 2 times 2. Okay, that's going to give us the first number. Next, 3 and 2 times this row, 2 and 3. So we're going to do 3 times 2 plus 2 times 3. And yeah, I'm sure if we'd picked more diverse numbers, this would probably be a little easier to follow. And then for the last one, we're doing, once again, this row times this third column. And that's going to go way over here on the right. So we're going to do 3 times 1 plus 2 times 4. Okay, so 3 times 1 is 3 plus 4, so we're going to have 7. We're going to have 6 plus 6, so 12, and then 11. Okay, so our final answer is going to be 7, 12, and 11. And I'm sure if you're seeing for the first time, this does look really tricky, and it is. It just takes a little bit of practice to get the pattern down. It is a very weird pattern, but you'll find that when we do word problems, this particular method of having to do this multiplication, it's very important that it's done this way so that the word problems make sense. So here's the actual rule written out for you. So like I said in the last slide, notice that the two inside numbers must be the same. Okay, K and K are there. And then whatever's on the outside there will become the dimensions of the new matrix, so the product in the end. So look down at the example below. We have a 2 by 1 matrix and a 2 by 3 matrix that we're multiplying together. Notice that this example right here, this cannot be done because the dimension here, 1 and then 2, those don't match up. So there's no way we could multiply this out and get a correct matrix. The example on the right, however, can be done, and this is the one we just did. Notice that we have two columns here and 2 rows, and as long as that matches up, we're going to be able to line up that multiplication and get an actual answer out. So always check that before you try any problem. Examples to follow here. 3 matrices. Go ahead and label their dimensions real quick. So A is a 3 by, 2 by 2. Okay. B is a 2 by 3, and C is a 3 by 2 matrix. First of all, AB. So AB. We have a 2 by 2, and then a 2 by 3. So remember, we're looking at, yes, those match up, and then in the end, we're going to have a 2 by 3 matrix as our answer. So that's what we want. Let's go ahead and work that problem out since we can do it. All right, and this is the tricky part, and again, it just takes a little bit of practice. We're going to do the top row of A with B. Okay, so the first column in B. So it's going to be 2 times 2 plus 1 times -4. Okay, and again, for this particular problem, don't worry about these right now. We're just looking at A times B. We're going to get a 2 by 3 in the end. All right. So for the next one, we're going to do, we use the same row times the next column. And you can do this in a different order. You can go down and do the second row in A and fill it out by columns instead. So really there's two different ways you can go about this. So we can do 2 and 1 and 1 and 3 now. So 2 times 1 plus 1 times 3. And then the last one, 2 and 1 and 0 and 5. So 2 times 0 plus 1 times 5. Okay, and that's going to give us the top row of our product matrix, the answer in the end. Let's go now and work with the bottom row of A and multiply that times the columns of B. So now it's going to be -1 and 3 times everything we just did. So let's try -1 and 3 against 2 and -4. So -1. Okay, so the first part of the row in A is going to be multiplied times the first part of the column in B. That's important to remember. That's the pattern here. And then the next number in the row will be multiplied by the next number in the column of B. So 3 times -4. Okay. For the bottom middle answer, we're going to do the same thing, -1 and 3, but this time times 1 and 3. So -1 times 1 plus 3 times 3. And for the last one, we'll do -1 and 3 and 0 and 5. So -1 times 0 plus 3 times 5. Okay, so we have our product matrix. We just haven't worked out the calculations yet, so let's do that. So we're going to get 2 times 2 is 4, plus -4 is 0. 2 plus 3 is 5. 5. -2 and -12, so -14. -1, so that's going to be 8. And then -1 times 0 is 0, plus, so that's 15. So this is going to be our final answer. So remember, we needed a 2 by 3 matrix, and that's what we got. So if you need a minute to just catch up or look at this again, you might want to pause the video, because I'm going to erase all this, and then we're going to work out B times A and then B times C. So here we go. Alright, starting fresh here. Now B times A, so let's, this is the one we're working with, B times A. So notice that we have, again, a 2 by 3, and we have a 2 by 2. So first of all, can this be done? So 2 by 3 and then a 2 by 2. Okay, now the inside numbers have to match, so 3 and 2. So this does not match, so this one is going to be called undefined. Alright, so now we can just go ahead and move on to the third problem. Alright, looking at B times C. B is a 2 times 3. C is a 3 by 2. Alright, so by lining those up, so now we're working with BC, we're going to get, we have a 2 by 3 and a 3 by 2. So this does work, and notice now the end, we need to get a 2 by, I'm going to write that out down here, a 2 by 2 matrix is our answer. Okay, so keep that in mind as we're working this out. So we're going to ignore A here and just look at B and C. So for the first part, on B, we're going to work with the horizontal, and then we're going to work vertically with C. So we're going to use the first row in B with the first column in C. So it's going to be 2 times 1 plus 1 times -1 plus 0 times 0. Okay? So elements in the row in B times the elements in the columns of C, all added together and following the order. Next, we're going to use the same row in B, and we're going to match that with the second column in C. So this time it's going to be 2 times 2 plus 1 times -2 plus 0 times 4. Okay, that's going to get us the top stuff. On the bottom, we're going to use the second row in B, and for the bottom left, we're going to use the left column in C. So -4 times 1 plus 3 times -1 plus 5 times 0. Alright, and next, same row, but the right column. So -4 times 2 plus 3 times -2 plus 5 times 4. Okay, so there's our 2 by 2 matrix, and of course we need to multiply and add everything up. So for the top left, we're going to get 2 minus 1 plus 0, so 1. For the top right, we're going to get 2 times 2 is 4, minus 2 is 2, plus 0, so just 2. The bottom left, we're going to get -4 minus 3, so -7, plus 0, so -7. And then on the bottom right, we're going to get -8 minus 6, so -14, plus 20, which is going to be +6. And there is our final answer.